The Robotic Industries Association wishes to thank the following member companies for their support, which made the production of this video possible. Though each is individually different, all robot systems share one common characteristic. Each can be a potential hazard for the personnel who operate, teach, or maintain it. Robots usually improve safety in the manufacturing environment because they remove humans from the need to perform dangerous tasks under hazardous conditions. However, robots can still cause serious injury if the personnel are improperly guarded or otherwise unaware of the potential hazards. The Robotic Industries Association, a leader in robot safety for over 25 years, has updated the American National Standard for the safe use of industrial robots and robot systems. This 1999 standard provides guidelines for the manufacture, remanufacture, installation, and safeguarding of industrial robots. Because every robot system is different, the standard should be used as the foundation for developing a specific safety training program suited individually to each robot application. The 1999 standard is divided into 14 sections. The scope, purpose, applications, and exclusions of the standard. Normative references. Definitions. Manufacture, remanufacture, and rebuild of robots. Performance requirements of safeguarding devices. Installation of robots and robot systems. Introduction to safeguarding of personnel. The prescribed method of safeguarding personnel. The risk assessment method of safeguarding personnel. The implementation of safeguarding personnel. Safeguarding devices. Maintenance of robots and robot systems. Testing of robots and robot systems. And safety training of personnel. Additionally, there are 5 informative annexes to help understanding the standard. This video presents an overview of those sections of the standard that specifically address the safeguarding of personnel. After viewing the program, the entire standard should be reviewed for more detailed information on robot safety. Every robot system is different in terms of size, speed of motion, and payload capacity. The following 3 examples illustrate some of the important ways that robots vary from one another. In our first example, the robot system performs a material handling function for an induction hardening process in the manufacture of front-wheel drive axles. The robots are mounted in an overhead or gantry position. The end effectors, the tools used by the robot to perform its task, are in this case grippers. Other end effectors might be suction cups, paint spray apparatus, loading electrodes, or metal cutting devices. In our second example, the robot is in a robotic tray handling system used by the United States Postal Service. In our final example, the robot system performs a general spot welding function for automotive body assembly. The cell is comprised of multiple robots, some pedestal mounted, some floor mounted. The robots use spot welding guns as end effectors. Another important difference between robot systems is the displacement at which the robot can move, as demonstrated in this animation. A robot's joints, such as its elbow and wrist, allow it to be flexible and move through large areas of space, both vertically and horizontally. When fully extended, this robot can move in an almost complete circle. The total space within which the robot can move is called its maximum space, shown here in tan. If a limiting device has been installed, the robot's movement for a particular application may be restricted to a smaller area, called the restricted space, shown here in blue. A limiting device restricts the robot's maximum space by stopping all robot motion independently of the control and application programs. Restricted space may change if the robot is installed in a different application and with different limiting devices. The robot performs its function within an even smaller space, called the operating space, shown here in purple. Again, the operating space can change if the robot is reprogrammed to perform a different task. Application, configuration, and space are just some of the ways in which robot systems can differ. Every system can be different, and every difference presents a new set of potential hazards for the personnel who work with it. Anyone manufacturing or remanufacturing a robot is required to uphold the safety of the future personnel who will be working on their robot. Of primary importance is to install control reliable safety circuitry so that any single component failure shall not prevent the stopping action of the robot. The pendant or teaching control device shall have an enhanced enabling device using a 3-position switch, which when continuously held in a detented position permits motion. Releasing or fully depressing the switch shall immediately stop the robot motion. Other important information about the manufacture, remanufacture, and rebuild of robots can be found in Section 4 of the Robot Safety Standard. A robot can carry heavy weights, move quickly over large distances, or use sharp or otherwise dangerous end effectors when performing a task. Personnel in the robot's environment can be at risk of injury if safety practices or procedures are not utilized. To maximize personnel safety in a robot environment, users must ensure that the system be installed in accordance with the installation guidelines presented in Section 6 of the Robot Safety Standard. The installation guidelines cover installation specifications, environmental conditions, location of robot controls, safety-related software, use of limiting devices, proper grounding, power disconnect, stopping circuits, equipment shutdown, and other important considerations. Refer to Section 6 of the Robot Safety Standard for more detailed information on robot installation. Personnel safety continues after robot installation by selecting a safeguarding method. The required safeguards per Section 8 are installed in accordance with Section 10. Or, per Section 9, a comprehensive risk assessment conducted to define appropriate safeguards and installed in accordance with Section 10. The prescribed safeguarding of personnel requires devices to prevent access to or stop the hazards without a deliberate action by the affected personnel. Prescribed safeguards are either mechanical devices or operating procedures used while the robot is in operation. The restricted space shall be established by installing limiting devices. Implementing safeguards requires safety circuitry limiting robot motion through mechanical limiting devices, like this hard stop shown here. There may also be non-mechanical limiting devices like this electromechanical limit switch, or others such as relays or blocking valves. Electrically integrated dynamic limiting devices may also be utilized, such as light curtains or control-activated retractable hard stops. Protection of personnel outside the restricted space shall be ensured by perimeter guarding, which establishes the safeguarded space by preventing access by interlock barriers and/or presence-sensing safeguarding devices. Here, an arc welding robot behind flash curtains is fed by a turntable. This system features prescribed safeguard devices, including presence sensing devices and barriers. There are several different presence sensing devices, including light curtains and safety match systems. A presence sensing device stops the motion of a robot if personnel enter the work cell. The motion cannot be restarted without deliberate activation. Barriers ensure that personnel cannot circumvent the device and reach the hazard without being detected. In this application, a high fence serves as a barrier. Barriers must cover an area between 12 inches and 60 inches off the floor as a minimum. Barriers shall contain hazards like loose parts, which would become projectiles. Flash curtains can also contain hazards, but mainly serve to protect the personnel's vision from the arc welding process. An interlock barrier, such as this interlocked access gate, allows access to the robot when necessary. If open, the robot's motion stops and cannot be restarted without deliberate activation. Like all robots, this system also includes awareness lights that warn the personnel of an approaching or present hazard. Personnel required to perform tasks within the safeguarded space shall be protected by preventing the reinitiation of any motion or hazardous process from any other source, providing clearance, limiting motion to allow speed, and compliance with teach requirements. Pendants used inside the safeguarded space must be equipped with an enabling device or function. The pendant shall have an emergency stop circuit and shall be designed with single point of control, so that initiation of the robot motion from any other source will be prevented. Point of operation hazards are usually a function of the robot end effector. For example, weld flash, spraying processes, grinding, and deburring may present hazards to operators, maintenance, teachers, or other personnel. Refer to Section 10 of the Robot Safety Standard for more detailed information on required safeguard implementation. To determine which safeguards are appropriate for an individual robot system, users may elect to perform a risk assessment in accordance with Section 9 of the Robot Safety Standard. Different robot systems need different safeguards. A risk assessment requires that the robot user consider the anticipated tasks associated with a particular application. Potential hazards are then matched to each task and assigned risk reduction values based on a decision matrix. Appropriate safeguards are selected based on the level of risk reduction necessary and then validated. For instance, a risk assessment for this robot considers that a normal task would be clearing machine jams.
System fault. Cell requires attention.
And the hazard to this task would be the potential robot motion. Interlock barrier guards would be a typical safeguard protection for personnel. The personnel who will be assigned to teach and operate the robot application will have sufficient training to safely perform their assigned tasks. By performing a risk assessment per Section 9 of the Robot Safety Standard, the robot user is able to carefully evaluate the hazards of this particular system before determining safeguards which will ensure maximum personnel safety when implemented in accordance with Section 10 of the Robot Safety Standard. Safeguards must be established for each operation associated with the robot system. These include teaching, operating, attended program verification, and maintenance. Teachers are those personnel who, as part of their job responsibility, provide the robot with a specific set of instructions necessary for the robot to perform its task. Teachers must become familiar with the particular robot and the manufacturer's recommended teaching procedures. Before beginning teaching procedures, the teacher must visually inspect the robot and its safeguard space to ensure that there are no existing conditions which may present hazards. He or she should check the emergency stop and the enabling device of the pendant to be certain that they are functioning correctly. In addition, the manufacturer has introduced measures to alert the teacher and require a response prior to the robot passing through or correcting for a singularity. Any malfunction must be repaired before teaching continues. The teacher must also verify that all necessary safeguards are in place. During the teach mode, the robot must be entirely under the teacher's control, that is, single point of control. It must operate under slow speed, less than 250 millimeters per second. The emergency stops must remain functional. And if movement of the surrounding equipment could create a hazard, those movements must also be under the teacher's control. Additional personnel entering the restricted space during teaching must have their own motion enabling device. Finally, the teacher must exit the workspace before automatic operation is initiated. Operators are those personnel who, as part of their job assignment, start, monitor, and stop the operation of a robot. An operator could be the person who starts the robot at the beginning of a work shift, or the person who feeds parts to the robot and initiates each cycle. The operator is responsible for verifying that the required safeguards are in place and in operation. The safeguards must prevent the operator from being in the restricted workspace during the robot motion, or prevent the robot from moving while any part of the operator's body is in the space. Operators should be trained to recognize known hazards associated with each assigned task involving the robot, and instructed in the proper operation of the robot system. Some robot applications require that personnel be in or near the restricted space while the robot is being checked that its programmed task is being performed correctly. This is referred to as attended program verification. Personnel assigned to perform APV have specific responsibilities directed to ensure their safety. Those working with a robot under attended program verification must have single point of control of the robot system. Initial application of drive power must be at slow speed, so that the operator would have sufficient time to either withdraw from the hazardous motion or stop the robot. The operator can then step up the robot speed to check for proper path following. All emergency stop devices must remain functional, and the operator must have sole control of the movement of other equipment in the restricted space. During attended program verification, the system must have specific capabilities which are presented in Section 10 of the Robot Safety Standard. Personnel who maintain a robot are responsible for keeping it in proper operating condition and restoring it to proper operating condition after damage or malfunction. These personnel must be properly trained to perform their task, and they must be safeguarded while working with the robot. Before entering the restricted space, maintenance personnel must visually inspect the robot to determine if any conditions exist which may present a hazard. If they will be using pendant controls, they should ensure that the motion control, emergency stop, and enabling device are functional. If not, they must be repaired before entering the robot's restricted space. Maintenance personnel must have control of the robot while they are in the restricted space. Control of the robot must be removed from automatic mode. He or she must have single point of control of the robot, as well as control of the movement of all other equipment that may present a hazard in the restricted space. All emergency stop devices must remain functional. Before restoring the robot to automatic operation, maintenance personnel should exit the restricted space.
Commencing system startup. Now in automatic operation.
Restore the safeguards that are required for automatic operation, and initiate a deliberate startup procedure. Additional safeguarding responsibilities for teachers, operators, and maintenance personnel are outlined in Section 10 of the Robot Safety Standard. The Robot Safety Standard contains more detailed guidelines that should be applied to each industrial robot or robot system. As a robot user, your safety and the safety of your fellow workers will be enhanced by adopting these guidelines and following other safety training programs that have been developed for your application. The Robotic Industries Association invites your participation in one of its standards development subcommittees. RIA is the only trade organization in North America organized specifically to serve the field of robotics. It has a wealth of resources for companies using or planning to use robotics. In addition to this standard on robot safety, the association also provides books, videotapes, CDs, market studies, supplier directories, and related information that can help your company more effectively utilize robot technology. The association also offers customized in-house training programs designed to meet your specific needs. For complete details on RIA membership benefits and user resources, visit our website or contact us. The Robotic Industries Association wishes to thank the following member companies for their support which made the production of this video possible. Adept Technology Incorporated, Advanced Research and Robotics Incorporated, ATS Robotics and Controls, Automated Concepts Incorporated, Banner Engineering Corporation, Bircher America Incorporated, Castell Interlocks Incorporated, CIM Systems Robotics, CIS Robotics, Classic Advanced Development Systems Incorporated, Columbia Okura LLC, Dyhen Incorporated, Flexicell Flexible Packaging Cells, General Motors Corporation, Genesis Systems Group, Honeywell Sensing and Control Industrial Safety Products, KUKA Robotics Corporation, Larco, Motoman Incorporated, Nachi Robotic Systems Incorporated, NCC Electronics, Panasonic Factory Automation Company, Phoenix Wirecloth Incorporated, Hills Automation Safety LP, Ram Center Incorporated, Rixan Associates Incorporated, Robotic Workspace Technologies Incorporated, Staubli, Tape Switch Corporation, Triad Controls, Twico Robotics, Wirecrafters Incorporated, Wright Industries Incorporated. We also want to thank the following companies for their assistance in this production.